I'm sorry. Let me try that again to make it easier to edit at the beginning. I'm going to go away and come back. Hello, and welcome to the Daily Space for today, February 6th, 2019. I am your host, Dr. Pamela Gay, and I am here with the mic turned on to put science into your brains. As always, we are going to do a quick run through of some of what's new in space and astronomy, but new and starting today, we're going to do a special extended episode to take on, well, one mission and telescope at a time. This week, we will be discussing the Pan-STARRS program out at Haleakala in Hawaii. Now, I appreciate the patience with all of you for helping me out with all of my twitchy audio issues and reminding me when things go sadly sideways. So in today's news, we have science coming to us from a variety of places in the solar system and here on the planet Earth, including in a laboratory where they have been draining water in order to understand black holes. Now, I admit when I first read this, I had this moment of, is this a science fair project or professional research? And it turns out sometimes it can be both. Well, it's not actually a science fair project, but it could be. It could be. In this particular situation, scientists working out of Silke Vernfurtner's group at the University of Nottingham have been playing with water in a special container that allows the water to drain out at the exact same rate that water is flowing in. This allows them to be dealing with a constant volume of water within the container. Now, they have clearly added various colors to this water, allowing it to be more photogenic. And that photogeneity is part of what they're aiming for. What they're trying to do is study what are the fluid dynamics of material falling in to a singularity-like event. Now, clearly your drain does not form a singularity at the base. That would be really bad. But the way material flows into this drain is very similar dynamically to how material flows into a black hole. It has to shed its angular momentum, waves and interactions build up, there's frictional, chaotic, turbulent interactions taking place. And by studying what's going on here, they're able to better understand what's going on out there with actual black holes. In looking at the system they've created in the laboratory, they were able to basically first start by looking to see what are all the individual waves that you can pick out of this interaction. Hey, Space Invaders. So here you see at m equals 0, where m is the wave number, it's just a smooth wave or a smooth surface. As you add the m equals 1 wave, you have this nice, beautiful S pattern. Complexity grows quickly as you add different kinds of waves, one on top, or different wave numbers, one on top of another. So here we have the negative wave numbers. So this is -1, -2. Now here we have the positive wave numbers. And when you convolve all these different wave numbers on top of each other, you get this sum, which they're finding greatly resembles the pattern of waves in the actual draining fluid. So this is really ingenious. It's the kind of thing that you look at and it's like, this is so simple. Why did no one do this before? This doesn't require anything more complicated than making sure that you have the same amount of fluid flowing in as flowing out of your wave system. So kudos to this team that pulled this idea together and is helping us have a more detailed understanding of the dynamics of material flowing into black holes. Now, beyond that, we have a story that's a bit more sad. This is an image of Mars that was taken by the Mars Cubesat B. Here you can see on the right-hand side of the image a bit of the Cubesat itself. Over on the left, you see the tip of the antenna, and off in the distance, well, Mars. Now, we didn't know how long Mars Co-A and B, the two CubeSats, really suitcase sats, that accompanied Mars InSight all the way to the red planet. We didn't know how long they'd last. That's part of what this experiment is meant to determine. So unfortunately, at this time, we're unable to communicate any longer with these two different satellites. This is something that has been a problem for a while. The two satellites got nicknamed Eve and Wall-E after characters in the Pan-STARRS film. The press release from JPL that I'm looking at doesn't tell me which one is A and B. But it does tell me that Wall-E was last heard from on December 29th, and Eve was last heard from on January 4th. Now, we're hearing about this today, I presume because during the government shutdown, we didn't need more sadness added into the world, and they have continued trying to make contact with these two little spacecraft. Unfortunately, they just haven't succeeded. At this point, the two missions are moving away from the sun, they're moving away from us, and in order for us to communicate, they have to be really well pointed. And it's possible that given how much more distant they are from the sun, that it's just too hard for them to use their brightness sensors to correctly align back on Earth. So they'll be moving back towards the sun come summer. NASA hasn't given up. We're going to continue listening, just like we're continuing to listen to Opie. So with spacecraft, you don't go by, with spacecraft, you do go by something you also go through with humans. Cold and dead isn't a thing. Something's not declared dead until it's warm and dead. So we'll keep listening until they warm up, come back to the sun, have a little bit more energy, and can really demonstrate whether they're still working or not. Oh, sadness. So as a cure to that sadness, I bring you a region of ionized gas. Now, if this looks familiar to you, it's because this is the same kind of physical structure as the ever constantly imaged Eagle Nebula and the Pillars of Creation. This is not the Eagle Nebula and the Pillars of Creation, but looking in this, you can see a lot of similar structures. You can see all of the striations in the gas. You can see a pillar down here that is still forming. This system is actually LHA 120-N180b, called N180b for short, and this particular system is off in the nearby Magellanic Clouds. It, like the Pillars of Creation and the Eagle Nebula, is a system of ionized hydrogen, massive star formation, and just plain beautiful. Now, this particular image, this was taken from here on the ground. This is demonstrating just what amazing work the Very Large Telescope down in Chile is capable of doing. And there's going to be a lot of science coming out of this. But for now, we have a pretty picture to enjoy. So I just have to point out, though, it kind of looks like a Muppet. I kind of keep expecting it to, like, close its mouth and eat cookies or something. So it's up to you to decide Muppet or H2 region. I kind of want it to be both. I now kind of really want a Muppet that looks like this. So here's for beautiful star formation and that brain cleanser we sometimes need. Now, those are my primary story. Nope, I lied. I have one more story for today. This is a story of collisions. Several months ago, there was a weirdo planet discovered around the star Kepler 107. This particular weirdo planet was one where there was a much heavier, denser than anticipated planet found in the outer parts of a solar system that had lighter weight planets internal to this planet. Now, the thing is, planets like the one depicted in this graphics, heavy planets are supposed to be on the inside of the solar system according to all of our models. According to our models, you get the high density material on the inside of the solar system, lighter density material on the outside of the solar system. Planets of higher densities form close in, planets of lower densities form further out. This is what they tell us. Now, that doesn't mean they're right, it's just what they tell us. Now, if that idea of how solar systems form and where heavier and lower density planets are supposed to form is correct, then the Kepler 107 system makes no sense, because they found that instead the star's two innermost planets, which are each roughly 1.57 times the size of the Earth, have dramatically different masses. So these are worlds that are about the same size, but the mass confined inside that size is different. So this is where you have a cubic meter of feathers compared to a cubic meter of water. One of these two you can hold up. Now, when they measured these two worlds, they found that the outer world was twice as dense. And our current understanding of planetary science just doesn't allow the outer world to be the one that is denser, because that dense stuff is supposed to settle in close to the star, not further out. So because it's more fun to make up new scenarios than to change our understanding of planetary situations, scientists went looking for ways to explain this craziness, to explain this high density world that is further out from the lower density world. And the idea they came up with is that this particular system is one that is the result of two worlds having a head-on collision, the smush making everything much higher density. The lower density material got flung away. And so this is actually, they theorize, the first example of a head-on collision resulting in a large world. Now, we know collisions take place. Our own world and moon are the result of a collision between, well, a smaller version of Earth and something roughly the size of Mars. So we know collisions happen. And I just love the fact that this is a possible solution. Now, at this point in time, there is no way to know for certain. Is this actually the result of a head-on collision, or is this rather just that we don't understand planetary formation? And really, we don't fully understand planetary formation. But it's cool to know that there's multiple models out there. And for now, we can go with what we think we know about planetary formation and say that this is just another example of violence in our solar system. So, I'm going to answer a few of your questions, and then I'm going to jump into today's extended story on pan-stars. So let's back up and see what all you guys have to ask. Kerbal01, what do you mean that Katie Mack's not happy? She's actually one of my more favorite humans. Thank you for all the subs. Let me see if I can trace back. So thank you, Astrohelge I don't know how to do that, for the bits. Thank you so much. I see a question. What constellation is that in? I'm assuming that you're talking about the Nebula. It is in the Magellanic Clouds. Let me get a better piece of information for you. It's in the Large Magellanic Cloud. It's not something you're going to be able to see with a small telescope. So if you look up N180b, you should be able to get the exact information on its coordinates. Okay. Yeah, it's Astro B. It is a bit disappointing that we've already lost contact with those CubeSats. Clearly, this is an experiment we're going to have to keep doing and keep perfecting until we do trust CubeSats to be our relay communication satellites in the outer solar system. Thank you, Lancy, for the Tier 1 subscription. Thank you, Fenrig, for gifting a sub to Hanny's Vorverp. Thank you so much. So Disillusioned is saying, I saw a New York Post article with a guy defending his statement that Oumuamua was an alien sail. Okay, so that is Ari Loeb at Harvard University. And I haven't read that article. What's interesting about the work coming out of Harvard is this is what it could be. This is completely consistent. But in science, all because something is completely consistent with the observable, if you have incomplete information, that doesn't mean that has to be what it is. There are other folks, after seeing our new results about the shape of 2014 MU69 being this conjoined set of bulbs, it is suggested that you can get similar crazy physics if you have this kind of a shape. I don't think we're done modeling that. Okay, so it's a Washington Post article. You can find multiple solutions. Some of them are going to be real, and some of them, well, most of them are going to be wrong. And the truth is usually partway in between two things you've suggested, because the universe tends to always be more creative than we are. So folks can say it's consistent with light sails, and yeah, it could be consistent with light sails depending on the shape model you use. But we don't have enough data to say that that's what it is for sure. So Hanny is asking, could Mercury's large core also be because of head-on collision? I don't know. One of the things that I've seen as an explanation for Mercury is that the young sun was able to blast most of the outer lighter weight material off the surface of Mercury early in our solar system's evolution, leaving behind only the higher density materials. As I said, there's always multiple ways to get at the same kind of thing. In this case, we have two different high-density worlds, one that is explained through a collision because of where it is, and the other one that is explained as, well, having its outer layers blasted off because of where it is. Okay. So London B is asking, yesterday you said we only see 4% of the universe out to the CMB. Does that mean 96% of the mass of the universe is beyond our visual horizon? So that was actually a limit. So at most, according to one of the papers I read, at most we're seeing 4% of our universe. It could be we're seeing like 1/1,000,000th of a percent. And yes, that does mean the majority of the dark matter, the majority of the dark energy, and the majority of the regular matter are all beyond our observable universe. Now, the thing is, when we're talking about how much of the universe's mass is dark matter, how much of the universe's mass is dark energy, and how much is baryonic material, we're actually talking about the percentage on average. And so here in my office, if I was to discuss the kinds of matter and restricting myself to the visible stuff or the detectable stuff, because that I actually have a possibility of understanding. I might say that the matter on Earth on average is some percentage metal, some percentage noble gases, some percentage, based on what I observe in my office. Now, if I go to a bigger room, I'll realize, oh, expletive. The average that I used was not actually average for everywhere. I need a bigger sample. Now, you can actually get a big enough sample of the planet Earth that you're able to say, based on that area that you're sampling, what the entirety of the Earth would be like. Now, with our universe, when we look out, we can see that different slices through the universe give us the same averages. So if I do a slice off in this direction out towards Andromeda, I get a ratio of materials. If I turn around and do a slice in the opposite direction, I get the same ratio of materials. So this allows us to believe, and this is the cosmological principle, that everything is the same everywhere. And that the ratios we see in our part of the universe, our observable part of the universe, are actually representative of the universe as a whole. So I can't tell you how much mass, how much energy, or any of that in total is in the universe. But I can tell you the ratios of the kinds of mass that we see. I can tell you the ratios of a lot of different things. And as a shortcut, we'll say that this is the percentage of this is the percentage of that. I hope that helps. Oh, Kerbal, that's bad to hear that Katie got misquoted. That is super frustrating. No one wants to be misquoted. Always let people record you if you're a scientist. So you're right, Stalker. Terraforming Mars would be a temporary process. We actually talked about this some yesterday. You could do it. It would be an awful waste of money and energy and effort, however, because over time, that atmosphere would just blow away. Okay, so I am going to switch on over and take a look at pan-stars as was requested yesterday. This is going to be a new thing that we try and do on a weekly basis as travel allows. You ask for more content and we're going to try and bring it. All we ask is that you show up to enjoy it. So, pan-stars. First of all, it's just pretty and photogenic. This little 1.6 meter telescope, which is part of a pair of 2 telescopes located out on Mount Haleakala. This is a volcano in the Hawaiian Islands. Well, pan-stars is a telescope set that is trying to, get busy observing the entire sky. And it fills an interesting niche. We have the Sloan Digital Sky Survey, which is doing a very small region on the sky in huge amounts of detail. It is doing very deep, high-resolution imaging of galaxies, stars, nebula, everything in that one footprint on the sky. We have previously the Digital Sky Survey, which was done with the Palomar telescopes in the northern and southern hemisphere. And it surveyed the sky once. It actually did it more than that to make sure it got everything right. But it wasn't looking for things that move. It wasn't looking for things that flicker and flare and transit. It was just mapping the whole sky. So we had Sloan, we still have Sloan Digital Sky Survey. We had the Palomar Digital Sky Survey. And these looked at the static sky in more and less detail. We have then had things like the Las Cumbres survey that is looking along the ecliptic of the night sky, looking for comets and asteroids and things that might hit us. Well, pan-stars is instead looking to image the entire night sky, roughly 4 different times per month, or at least everything that is visible from its perch in Hawaii, which is a great deal of the northern and southern sky as the sky passes by throughout the year. And as it's doing this over and over and over, it's trying to map out everything brighter than about 24th magnitude, which is like fainter than you're going to get with anything you could personally own. This particular telescope, it takes kind of cruddy images, but what it does is kind of breathtaking. So its first goal is to map everything that is what's called a near-Earth asteroid, a near-Earth object, rather. These near-Earth objects fall into 3 different categories. You have the Amor ones that are named after one of the members of this category, the Amor asteroid. And these are objects that come near the Earth in their orbit, but are always slightly outside of the Earth. So they aren't Earth crossing. They're probably not going to kill us. We also have the Apollo-class asteroids. These are objects like the rock that tried to take out the Russian city of Chelyabinsk on Valentine's Day several years ago. Apollo-class asteroids are, again, on fairly round orbits, but here their orbits cross Earth's orbit. These can kill us. These we don't like. And then you have the Aten objects. These, in their closest point to the sun, are closer to the sun than Earth by a lot, and are out near the distance of Earth's orbit when they are furthest from the sun. These are highly elliptical objects, and these are kind of the most likely to kill us. This is because they spend the bulk of their time in near the sun, come whipping out of the sun towards us. And when something's near the sun on the sky, it's really hard to see. So trying to understand these different objects and their different paths through the sky is something that we do in order to try and prevent planetary death. For this reason, these telescopes, the Pan-STARRS 1 and 2 telescopes, were actually funded by the U.S. Air Force. The work itself is being done by a consortium of different universities, the University of Hawaii, MIT MIT Lincoln Labs. These are all different institutions that are involved in this as we try and protect our planet. Now, Pan-STARRS is responsible for some rather famous objects. For instance, Pan-STARRS back in 2017 presented us with 1I 217 U1 Oumuamua. This was actually a discovery of the Pan-STARRS mission. Unfortunately, Pan-STARRS didn't find it until it was already on its way out of the solar system. It turns out observing the entire sky from where you are 4 times a month is not always enough. But it did find it. And now we are in a position where Pan-STARRS has given us this amazing view of our sky. This is the majority of the sky it is observed, stretched out into a standard map projection. And that arc that you see that looks a bit like the St. Louis Arch is actually the disk of our own Milky Way galaxy, where you can see the center of the galaxy off on the right-hand side of this image. This is a compilation of 500,000 45-second exposures. More than 500,000 individual images have been stitched together to bring us this view. Pan-STARRS itself is able to see roughly 3 degrees of the sky per image. And the pixels are a bit big. This isn't the kind of system that you use if you want to get beautiful pictures of individual distant galaxies. This is the kind of telescope that you use when you're just trying to figure out where things are on the sky and measure their color in a variety of different filters. Pan-STARRS is actually taking images in 5 different filters each month as it chews through the sky, and these 5 filters are consistent with the Sloan Digital Sky Survey, allowing us to go back and forth between images taken with both these different systems. Now, with Pan-STARRS, their primary goal is to make sure we don't die by asteroid or comet or any other things that are moving through our solar system. And so Pan-STARRS is now responsible for a larger and larger every year percentage of the objects being found moving through our own solar system. In addition to finding the things that are in orbit near us, it's also finding asteroid belt objects. It's looking for Kuiper belt objects. It's filling in all the missing mass, one large chunk of dirt, dust, and ice at a time. Beyond our solar system, it is mapping all of the stars, all of the distant objects, all of the anything that is brighter than 24th magnitude. Like I said, these are not high-resolution images, but these are the kinds of images that are going to allow the astute photometrist, the person who measures the brightness of objects, to go through and start to do interesting science. For instance, with this data, you can get amazing maps of where are all the Cepheid variables in our galaxy and in nearby galaxies. And you can start to more, carefully map out the exact structure of these systems. Yesterday, this came up in a discussion of how our galaxy is warped and how this discovery was made by looking at Cepheid variables. Now, that wasn't a discovery that came entirely out of Pan-STARRS data, but this is the kind of science that Pan-STARRS is going to allow. So we are currently at the point where Pan-STARRS has now put out the largest data dump ever made. And I have to correct myself. Earlier I said that these are 1.6 meter telescopes. They're actually 1.8 meter telescopes. That 1.6 is how many petabytes of data that Pan-STARRS just released. That 1.6 petabytes of data is 30,000 times the amount of data that's in Wikipedia, to give you one small example of how much data that actually is. That 1.6 petabytes is stored on the servers at the Space Telescope Science Institute and is freely accessible by everyone. So, do you have a cool question you want to ask using photometric data of a whole lot of objects in the sky? The data is there. All you have to do is click on over and dig in. So that concludes all the science I wanted to discuss today. I do have a couple of things that I want to announce. I don't know about you, but I am currently doing it's cold outside. I want to imagine going somewhere warm. But because of work and school and everything else, I'm not traveling anywhere till summer. So as I make plans for summer, I'm going to get to do some cool things that hopefully you get to join me on. This is the Astro Tours All-Stars Party. You can see me, you can see Skylius, who's another streamer here on Twitch. You can go meet Paul Matt Sutter, John Mitchell Goodyear. We're all going to be there at Joshua Tree come June 26th through the 30th. And this is something that's a bit, close to my heart, because as our environment changes, certain plants and animals are no longer going to be located in the places they need to be to continue living. The ecology around Joshua Tree National Park is changing. Some of these trees were vandalized and cut down during the government shutdown, and it's looking like these trees will never be able to grow back. So before more harm is done to the park, I want to get out there, and I'll probably actually hug a tree so that we can post it on Instagram. But there's also going to be stars and dark skies and stories told. And you're all invited to come join us. It's not free, but Paul and the tour group that he works with do an amazing job at putting together lodgings and other things so that you can come out, join us, and have an amazing experience out in the dark skies. I am promised there will be partying, and I, for one, am going to take a hammock and binoculars and invite you to kick back and look up with me. Now, if you are still busy in June, I know when I was growing up, I was still often in school come the end of June, and school didn't always get out till the 4th of July. It was Massachusetts. There were a lot of school days. Well, we have other options for you. If you are interested in exploring the American Southwest, which is my favorite part of the world, you can join me at the end of summer. We will be traveling from Tucson, Arizona up to Las Vegas, baby, and seeing all the astronomy that lies between. So come see the sky and share the American Midwest. And I promise you beauty, I promise you science, and I hope you can promise me to be there. So let's vacation together and get out under the stars. Okay, so those are today's science, spacecraft, and everything else tales to consider. I'm going to pull up the chat and go ahead and answer more of your questions. So I see Henny's Vorverb asking, will there be a lesson on probability on the Vegas trip? Yes, I'm sure at some point I will definitely be discussing probability as it relates to various games that you can experience in Las Vegas. I, for one, am hoping to go catch a few shows. Yeah, gambling facilities. They also have, however, amazing shows. And magic. So I have the link for Pan-STARRS at Space Telescope. That's the link for Pan-STARRS at Space Telescope. All the smart people in one place. That is our goal. Hey, Archie Haddock. I think I got you the link you needed. PETA, I need to look up exactly. I think you're right, but I am going to fact check. PETA in scientific notation. I was that kid who could only remember things like that so long. Yes, 10 to the 15 is PETA. Yeah, time to buy stock in hard drives. The data is totally publicly available. This is one of the things that we try really hard to do in the United States, and that's when telescopes, science observations, things like that are paid for with tax dollars. We work to put it out into the public domain. This means that scientists beyond those that were funded for any one individual piece of research will also be able to utilize the data. This also means that if in like the worst of all possible cases, you can imagine a scientist gets their time on Hubble, VLA, whatever massive observing facility it is, they get their data, and then they get cancer, and they're never able to finish the research they intended. Well, it would be a shame if that data was never set free to be worked on. So we don't let things like that happen. There's also chances to go back and use data to study an object that wasn't what was the intended target, but happened to be in the field of view. A background galaxy that when the observation was taken didn't have a supernova in it, but today does. So we put the data where anyone can get it. Thank you, Archie, so much for the follow. Thank you. Okay, looking to see. Am I starring on Weekly Space Hangout later today? They haven't said that they need me. If they do, I will come with bells on my shoes. Okay, other questions. So thank you, Herleu, for the subscription. Thank you so much. Herleu is one of our programmers here at CosmoQuest. I see questions about why we put different telescopes in different places. where we put them depends on exactly what kind of science we're trying to do. Hawaii is fabulous because it's not too far off the equator. It has high altitude peaks that are fairly easy to get access to. There's airplane flights in and out of the island. It's equally horrible to get there for anyone on the planet, pretty much. Chile, however, has the highest, driest mountain peaks in the world. This means that if you're trying to make observations in the infrared, that's where you want to be. It has multiple large plateaus, mountains that you can turn into plateaus, and this is where we tend to be putting the largest observatories in the world right now. Now, you're not going to be as near the equator when you're in Chile. So when we partner things, what we often try and do is get something in the north and in the south. Hawaii is north of the equator. It can get the entire northern sky. So in the best of all possible worlds, which is what we did with Gemini North and South, we stick one observatory in Hawaii, one observatory in Chile, and then we get everything. The Canary Islands suffer from being surrounded by places with humans. The Mediterranean is a whole lot smaller than the Pacific Ocean. So there is light pollution off in the distance. It's not a lot, but it's there. Its weather also isn't quite as good as you get in other places. And it's a whole lot less altitude. That lower altitude means that you're looking through more of the atmosphere, you're being affected by more of the atmosphere, and more to the point, you have more water vapor blocking those infrared wavelengths. Every place has its own pros and cons. The thing about the Canary Islands is if you are an astronomer in Europe and you're building instrumentation, you're trying to do a special project, the Canary Islands are right there. So it's easier to get to them than it is to get to Hawaii. So choices get made. The other thing is you have to consider the needs of the local people. Hawaii, we're always building on holy sites. And this is a secular nation that claims to hold religious freedom of value and claims to respect the indigenous peoples of the land that we now live in. And many of the people in Hawaii who are native to Hawaii, which was a great nation, they don't want those telescopes there. That land is only leased for so long. And who knows what's going to happen when the lease turns over. That's part of why the 30-meter probably isn't going to be built in Hawaii. Now, in Chile, they view getting these telescopes as an amazing economic boom. This is helping their nation. Similar things are happening in the Canary Islands. So we need to be respectful of the different places that we build, of the people that live there, and educate them and take care of them and not just desecrate their lands. So many different factors to consider. Okay, let's look and see what other questions have come in. So Hanny's Warverp, currently we're not seeing quantum computing as being useful for solving regular everyday problems. Not yet, at least. Yeah, Atacama really doesn't rain. That is entirely true. It really does not rain in Atacama. I do not have the space for 1.6 petabytes. So here is a challenge for all you mods out there. Last night, I gifted Nightbot a sub, which means Nightbot can now use emotes. So you are all challenged, should you choose to accept it, to add emotes to the things that Nightbot says. But anyways, I think that is going to conclude today's episode. Oh, no, more questions coming in. Hanny is asking, do you know if AI is being used on any of the large data sets? Oh, yeah. We use AI on all the large data sets. Sometimes we call it machine learning, sometimes we call it neural networks, but these are all different forms of artificial intelligence. Yes, this is a survival mechanism. Otherwise, you can't really get science out of things this big. So Fenrig, thank you, Susie, for the Twitch Prime sub. Thank you so much. So Fenring is asking, and light up the chat. It hasn't gotten lit up nearly enough for all the subs we've had come in. So Fenrig is saying, can Earth's collision with Theia explain why Earth is densest solar system planet? Yes, it can. And the moon is also disproportionately lower density. And this is simply the splash of the low density material after the collision. So Archie Haddock is asking, how often did you stream? I am glad you asked. The Daily Space is brought to you most Mondays through Fridays at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. Sometimes I'm not here and we have Binary Ablaze. That's Annie Wilson stepping in. We are also here for most interesting rocket launches. If it's at 2 a.m., we may not decide to get up. So Susie or I will come to you and discuss the mission. We can have a shared viewing party as we watch these missions take off to orbit and beyond. We also bring you press conferences as they happen, when they happen. So you can count on us being here most Mondays through Fridays and lots of other random times. So, well, you already did the right thing. You gave us a follow. Follow. It's free. And it lets you know whenever we're going live. We're going to be adding more and more content in the months to come. So I hope you come along with us for the ride. We are going to be bringing back Daily Space once again. It's one of those shows that comes and goes as busyness occurs. And I'm looking to start adding classes and a variety of other things. I took notes and we'll add things as we can. Yeah, we need to learn about the co-streaming technology that Twitch is just adding. You are on, oh man, I don't know my flags as well as I should. That looks like it's probably a British colony. I don't know what flag that is, Archie Haddock. What flag is that? Actually, if I mouse over, does it tell me? No, it does not tell me. Oh, wait, is that Norway? Is that a Scandinavian flag? I don't know what flag that is. Hello, Haunted Broccoli. I love your username. That is fabulous. That is absolutely fabulous. I know geography. I don't know flags. Norse. So it is Norway. Okay, cool. I have not been to Norway. Have I been to Norway? No, I've been to Finland. I've been to Finland several times. I haven't been to Norway. So you are London +2. This means we're on 8 p.m. Most Mondays through Fridays for you, if I did my time zones correctly. So Dick Circt is asking a question. Let me scan through it. So Dick Circt says, this may be off topic, but since you're in the field, if a school offers a BA in astronomy with special astrophysics track, is that better or worse than just a BS in physics? It's actually a whole lot better. That's actually exactly what I did. I went to Michigan State University, where they have a physics program that allows you to specialize in various subfields. I did my specialty in astronomy, and what this meant was my capstone program already had me doing astronomy research. And if you want to get into an astronomy PhD program, it's so competitive that you pretty much need to be on a published paper before you graduate. It's hard. It's really hard. It's super competitive. But if there's a physics program that you can get into that has that special astronomy track, you'll also be happier because you'll be doing some of the stuff you love at a younger age. So Astro London is saying, is there an online telescope we can log into and watch? SLOOH sort of counts, I think. SLOOH Not really sure if it's what you're looking for, but it's the one that comes to mind. Yes, Hannes Vorwerp. There are parts of Norway, Scandinavia, all the Scandinavian nations where during the summer months, the sun never sets. This is called White Nights. It was made famous by a movie with a ballet dancer in it back in the 80s, Mikhail Baryshnikov, and it talked about Leningrad, which is now St. Petersburg. Anyways, you go far enough north, and there are times in the year where the sun just seems to skirt around the edge of the horizon rather than actually setting. Now, the consequence is there's also times in winter when the sun never rises. Helsinki, many of the other not quite so far north cities do give you a few hours of darkness and a few hours of daylight, but it's really rather bright or dark, pick one. It's planetary rotation's a kind of cool thing. I advise you to get software like Stellarium, which is free, and just play around with putting yourself on various parts of the planet and watching the world turn. So Jandralun, Norway, I think, is the nation that has a rocket launch pad that they use for sounding rockets to study the northern lights, if I'm remembering that correctly. Oh, you're above the Arctic Circle? Dang. So you are currently getting, all darkness all the time, if I remember my geography correctly. Well, it depends on exactly where you are above the Arctic Circle. Oof, that's no good. March is coming. The sun is coming back slowly. I have heard that there are hotels, Susie, going along with your desire to visit, that there are hotels in Norway and Finland where each room is actually an igloo-shaped cabin that has solid walls up to like above a normal human's head height. And then it's a domed skylight so that you can lie in bed and watch the northern lights. And going and staying in a place like that is actually on my bucket list of things to do someday. Yeah. Oh, wow, Archie. I'm so glad you have the sun back. I'm so glad. I didn't know that pad almost caused World War III. Can you send me a link about that? I'd love to read about that. Thank you, Kerbal. I love it when you guys know things I don't, because I can learn from you guys too. Because you guys all like space, there's always these opportunities for you to have read something I haven't got to, and it's just awesome. Svalbard is above the Arctic Circle, and it has polar bears. A lot of polar bears, a lot of them. Okay, so I think I've caught up on the chat. I think I've answered all of your questions. And I think it's time for me to go find lunch and get back to work. I will be returning tomorrow to bring you more space and science. As always, the Daily Space is a production of CosmoQuest, and we are part of the Planetary Science Institute, working in collaboration with Youngstown State University. We are here most Mondays through Fridays, 10 a.m. Pacific, 1 p.m. Eastern. That's 6 p.m. London time, and I think it's 8 p.m. for those of you who are in that time zone that goes up through Scandinavia, but I may be wrong, so please don't hold me to it. Give us a follow. They're free. And if you are watching this on Twitch, thank you for being here live. And if you ever miss an episode, go check us out on YouTube. Every episode gets posted a little bit later in the day. And subscribe to us on YouTube. It really helps us out in getting found in the search results. So please click on over to YouTube and click that subscribe button. And if you're watching this on YouTube, know that you can always catch us live and ask questions in real time. So I am going to roll the credits, and after I am done rolling the credits, I am going to find, well, actually, while I'm rolling the credits, I'm going to find someone to raid on over to so that you can keep the science rolling. Now, if anyone has any suggestions of people to raid that are doing science or other learning, I am always open to ideas. I'm also apparently open to blocking the bottom bit of my monitor, making it really hard for me to pull up Discord and see who else is streaming at the moment. So we have Kit Boga is currently streaming. We have, I think, Adam13531, who is another coder, is streaming currently. Let me see if he's still going, and if he is, I think we're going to give Adam a raid. And I'd ask all of you to light up his chat with a friendly, yep, he's still streaming. Light up his chat with a friendly CosmoQuest hello. So thank you so much for being here. Thank you for bringing the questions. Thank you for bringing me random things I didn't know and helping me find out things like Scandinavia almost caused World War III. And wherever you are in the world, have a fabulous morning, evening, afternoon. If it's safe and warm enough to go outside, get outside and look up. And I'll see you tomorrow. Bye-bye.